Welcome to qnawire.
For this problem on the topic of quantum mechanics, we are given a possible wave function for a free particle which has a mass m to be psi of x is equal to e to the power kappa x when x is less than 0, and e to the minus kappa x when x is greater than or equal to 0, where kappa is some positive constant. We want to first graph this wave function, and we want to then show that this wave function satisfies Schrodinger's equation for x less than 0, where the energy E is minus h bar squared kappa squared over 2m. We then want to show that this wave function also satisfies Schrodinger equation for x greater than or equal to 0 with the same energy as in B, and then want to explain why the wave function that is proposed is not an acceptable solution of the Schrodinger equation for a free particle. So we've sketched the graph as follows, with psi of x versus x over kappa. And so going on to part B, we have that x less than 0 gives us psi of x equal to e to the positive kappa times x, which means that d psi dx is equal to kappa e to the kappa x, and the second derivative, d2 psi dx squared, is equal to kappa squared e to the kappa x. So this means that the constant kappa squared is equal to minus 2m over h bar squared times e from the Schrodinger equation. So this is a solution to Schrodinger's equation, provided that e is minus h bar squared kappa squared over 2m, which is the provided requirement. Now for part C, if we go into the region x greater than 0, we have the wave function psi to be e to the minus kappa x, and so taking the first derivative d psi dx gives us minus kappa e to the minus kappa x, and taking the second derivative with respect to x, d2 psi dx squared gives us kappa squared e to the minus kappa x. So again, we have kappa squared to equal minus 2m over h bar squared e, which means that the energy E is equal to minus h bar squared kappa squared divided by 2m, again, which is the requirement. Now, lastly, we want to show why this proposed wave function is not a viable solution to Schrodinger's equation. And we can see that d psi dx is discontinuous at x is equal to 0. And so that is, it is negative for x greater than 0 and positive for x less than 0. And so this says that the wave function psi is not an acceptable one. And d psi dx must be continuous everywhere except where the potential energy U approaches infinity.